All right, let's talk about the second way in which we can do spotwelds inside Ansys LS-Dyna. So I'm going to talk about the constrained generalized weld spot, which is very similar to the first way that we discussed, except in this case, it allows modeling of other weld types. So it is actually slightly more robust, has a little bit more options. In addition to that, the constraints generalized weld spot can model other type of welds, right? So in the documentation, you can see the first option is what we're going to talk about today, but you can also model other type of welds, which gives you a lot more options to model the different weld behaviors by just choosing a slightly different keycard. This is why Dyna is so awesome, because you essentially have the freedom to do a lot more by just manipulating the keyword files. Okay, so let's take a look at how to do this, right? Basically, uh, it doesn't support solid elements, so I'm not gonna model anything with a solid element. I'm just gonna use shell elements, just similar to the last problems. So the example problem is similar to the last time, right? We'll still have two pieces of sheet metal parts. You know, we're going to do the same thing. We're gonna create a key card that's gonna sort of create a nodal constraint between the two nodes. So let's just go through the motion real quick. 12.7, 12.7 here as well, right? I'm going to go ahead and going to generate a face mesh, which is going to generate a structure mesh on these two parts, right? The sizing is correct, and let's go ahead and match that. Similar to last time, I'm still going to create a constraint between this node and this node. But the difference between the constraint spot weld and the constraint generalized weld spot, right, the two is that they have a slightly different methodology. In this case, what we have to do is to create a node set. The node set is going to be what's used inside inside the keyword, right? So what I'm gonna do here is I select both of these nodes, which are gonna be tied together, and then I'm gonna create a name selection. I'm gonna call this the node set. So you can see that in the name selection region, I have a node set now created with these two nodes, right? And then I'm going to create an ID 999. Now the node set 999 is going to be basically the node set that I will reference when I'm generating the nodal constraint, right? And then let's go ahead and just do that. I'm gonna call this constrained generalized weld spot. Right? No, similar to before, I'm going to use a keyword template that I've already used before to do this. So let's go ahead and do that. Constrained, let's see if I can find my card. Constrained generalized weld spot right there. Let's go ahead and use this. All right. So what happens in here is that I have a node set ID 00999. I'm going to reference this node set, and then I'm going to define a 10,000 normal and a 50,000 shear Newton force threshold. So if we look at the keycard real quick, right? Well, spot, as you can see, the first keyword really doesn't matter that much. All we have to do is define a node set ID. Now we're gonna be using the default coordinate systems, right? Everything else leave it as zero as default. And then we're only setting a normal force and a shear force at failure. We're not setting any of the other parameters. You can certainly play around with those. But to demonstrate the idea of this this functionality, right? I'm just gonna go ahead and just similar to the last problem, I'm gonna go ahead and set these two parameters. And together, that's going to help us sort of define the behavior of this nodal constraint, this nodal pair, right? Same thing, I'm gonna do a 0.2 millisecond termination time, right? And same thing as last time, I'm going to do a fixed support on one end, and I'm gonna do a displacement on the other end, right? And then in this case, I'm going to set the displacement to 2 millimeters, right? And then I'm going to add a database card, as I've done in the last problems. Very quick. Same thing, the database card is going to be the same one we used last time. I'm going to set about 1/100th of the termination time, give us 100 data points to look at. Okay, and that's it. That's a very simple model, right? We have two sheet metal parts. We're linking them together by calling a 999 nodal set. The nodal set is basically linking these two nodes together, right? And then I'm going to write out an input file to take a look at it. Let's call this the demo constrained generalized Spotweld. All right, that's it. Let's open up Alice Purpose. I'm gonna drag it to my other screen so I can quickly look at this. All right. So once I have the input file, I'm gonna drag it over and let's take a look at it together, right? So as you can see, if I were to just to inspect the general card, I can see there is a nodal pair that's being generated through the constrained generalized weld spot keyword file right here, exactly as we wanted, right? Okay, do a quick check for the model checking. Everything looks good, right? All right, let's go ahead and solve it. If it's gonna show up. All right, let's look at. This should solve instantaneously, hopefully. I don't know why my window is so large. Okay, I think that finished. And let's go ahead and drag the result file over. So let's take a look at the result file together. All right, same thing. You know, it's a very similar process as the last video, right? But it mostly shows a slightly different way to model the same thing. And we can see this thing ends about 25,000 as one would expect, right? And then I'm going to filter this data out a little bit so it's not as noisy. Right, so you can see this thing sort of the failure starts at around 25,000 newtons, right? Which is, you know, half of the total force. One on one side you have 25,000, on the other side you have 25,000, and at that point the failure occurred around that spot weld, similar to the last problem, right? Basically the same results with two different keywords. All right, thank you.